Okay, so in this video we're still talking about the normal distribution, but this time we're talking about calculating quartiles. You probably have done basic statistic analysis before in previous classes where you had to calculate the mean, median, mode, quartile 1, quartile 3. That's what we're focusing on this video, is quartile 1 and quartile 3. Remember from previous classes that quartile 1 represents the 25% marker of a data distribution, and the quartile 3 represents the 75% marker of the data distribution. Same thing is still true here, so keep that in mind. We have two formulas, one for quartile 1, it's the mean minus 0.675 times the standard deviation. Quartile 3 is essentially the same thing, the only difference is instead of minus in the middle, we have plus in the middle. The numbers are still the same, we still have the mean, 0.675, and standard deviation. So here in this example, we're told that we have a data set of 1,494,531 people in this normal distribution, and that distribution has a mean value of 515 and a standard deviation value of 114. We're going to use this information to describe the spread of the distribution and to calculate the first quartile and the third quartile of the distribution. So I'm going to start with the quartiles, Q1 and Q3, and that was just using those two formulas that you just saw. So for Q1, we know it's approximately the mean minus 0.675 times our standard deviation. Well, we're told in this problem that our standard deviation was 515, so Q1 is equal to 515 minus 0.675 times our standard deviation, which we were told is 114. Well, now we're just going to use calculator. Nothing hard here. So we have 515 minus 0.675 times 114. And so our first quartile is at 438.05. Okay. Our third quartile is essentially the same formula, but instead of minus, we're going to have plus. So Q3 is approximately the mean plus 0.675 of the standard deviation. Plug in what we know. So the mean again was 515 plus 0.675 times the standard deviation, which was 114. Again, we're going to use our calculator to do that. So 515 plus 0.675 times 114 is 591.95. Okay, so now we can use this information that we have given to us in the problem and what we just calculated to describe this distribution. First off, we know for a normal distribution that the mean is in the exact middle. So that means 50% of the data in this distribution lies below 515 and 50% of the data in this distribution lies above 515. We also know that for the quartile 1, which represents our 25% marker, that 25%, so approximately at 438, that's 25% of the distribution for this data set. Same thing for quartile 3. Quartile 3 is our 75% marker of this data set. So at quartile 3, we have 591.95, or approximately 592. So 592 is approximately set at our 75% marker. Now, if we think of the difference, so this was 25%, and this was 75%. Well, the difference between 75% and 25% is 50%. So these values that fall between all the values in the data set that fall between 592 and 438 in the data set, that's approximately 50% of all values in this data distribution. So that's a big chunk. All the other values are going to be on the either below 25% or above 75%. So if it helps you draw it out. So that's what I want to do. I want to draw a sketch of the normal curve. We know that the mean value goes in the middle. That's 515. That was our mean. We know that 75%, so this was our 50% marker. At 75% was approximately 591, or 592 I should say. And then 25% was approximately 438. So this was 25%. This was 75%. Again, this was Q1, Q3. So what I just said here is that 50% of the data lies in this range between Q1 and Q3. The other 50% of the data lies outside of this range, either below 25% or above 75%. Okay? But that's how we can use the information that we have and the information, the formulas we just had for the quartiles to describe a normal distribution. And that's it for this video.